Isn't that cool? All right. So, so did we graph this yet?
No.
No, we didn't. All right. So -3, -2, -1, 0, 1, 2, 3.
You could always post this on YouTube after and be all cool and be like,
Uh-huh.
I'm a teacher.
My
I
math
have
teacher.
a whole bunch of my videos up on YouTube.
Really? That's so
Yeah,
cool.
calculus. All right. So
Dog man.
we're doing -1. I'm sorry, 1/2. 1/2 to the x.
So then it's switched, so all the negative numbers will be whole numbers, all the positive numbers will be fractions.
Do we agree with Katrin?
I guess.
Sure.
Let's just check one of them. 1/2 to the 3rd power.
Is 1/8.
Right, it's 1/2 times 1/2, which is
1/4.
1/4 times 1/2, which makes
1/8.
1/8. So this is 1/8 here. So this is going to be 1/4, 1/2. How about to the 0?
1.
Still 1.
2, 4, 8.
Great.
So it's just back.
It is just backwards. So without filling in all the details here, we're just doing this. And we see that as we go from left to right, the y values are getting,
Large, what? Left to right, smaller.
as we go from left to right, the y values are getting smaller. In the other graph that we drew before, the y values got
Bigger.
bigger. So what conclusion can we draw by looking at those two examples? One of them was y equals 2 to the x, and that grew. And this one decayed.
So fractions.
So if our base is
A fraction.
a fraction, less than 1, then we have exponential decay. If our base is more than 1, we have exponential growth.
Okay.
So if base greater than 1, then growth. If base less than 1, then decay. Ja, gut. Questions? Anyone?
Negative.
Bueller?
Bueller?
Ferris Bueller? Come on now.
You never see Ferris Bueller Day Off?
Nope, page turn.
You should.
I need to go.
Are you leaving with the PSAT people? Yeah.
I
I guess.
have
I don't know.
not seen several classics.
What's our homework?
Only
Some
classics
work.
I've seen are Disney classics.
All of it?
All the stuff that's up there.
All those guys.
So I'm also going to try to post that on Google Classroom also.
I've seen that. I've seen,
Where are we going?
132.
So before we start sketching exponential functions,
Stop.
I want to do some sketching of quadratic functions, which we know lots about already. I know.
Casual.
So what does y equals x squared look like? Meh.
Does that say page 226?
1 to 10 and 17 to 22. And graphing.
How about y equals x squared plus 1? What does that look like?
Up. 1.
Up 1. Same shape. Up 1. Everyone's coolio?
Yeah.
How about y equals x minus 2 squared? What does that look like?
Math.
Over to the right, and it's a over to the right.
Over
two.
to the left, too.
Yeah, left 2.
No, it's right. It's negative. So it's gonna go to the right too.
No.
How do we
yeah,
know?
my bad.
Right? Because we always want to make that 0.
So it's over to the right two.
Yep.
And it's just a U.
Still a U shape, moved over 2. To the right.
Shut.
Everyone's okay?
See.
We remember these transformations, don't we?
Yep.
Let's go.
Great. So I want to use these transformational concepts with our new parent functions, our new shapes.
Oh God.
I know,
Why?
Because he hates us.
because we can.
Why do we have to?
Because that's what the objective is.
Why is this a thing? Why does this exist?
Why do you exist?
Why do you exist?
Because the big elephant in the sky, also the flying spaghetti monster.
Or the turtles.
Mm-hmm.
Or Jesus?
So 2 to the x plus 1. So, so those of you who are playing on your calculators, not mention anyone by name, and not writing anything down in their notebooks,
He's still gonna get 100. Why do you say it?
still not mention anyone by name. Let's write this down, please.
I don't understand how this happens. Like,
You're just a mess.
I don't get it.
Okay, so 2 to the x plus 1. So what does the shape 2 to the x look like? We already know. The gaming chair, right?
Meow.
Good chair.
Game chair. And it's the game chair that's been
Plus 1.
moved which
Up,
way?
this way.
Up 1. So, when we had our rational functions that we worked with, and rational functions have asymptotes, what did we do when we moved the rational function around? What did we do?
We did draw it.
We had to draw in a new asymptote.
Oh,
So our old asymptote was,
1. Or 0. So what would become 1 because you're
right,
adding
it was y equals 0, but now we've added 1, so our new asymptote
y equals 1.
is right here.
So the asymptote is the.
In this
One?
case, it is this, yes. It's that.
I don't.
Is it because it can no longer be the y intercept because it's 2, but it wouldn't make sense to have it like. I had it figured out and very nicely worded, and then I tried to get out of my mouth, and it didn't
Okay.
work.
So, we know that our parent function passes through, or has a y-intercept of
1.
1, which is really just 1 above the asymptote. So we're going to go 1 above the asymptote and draw in our shape. So we draw the asymptote, and then we go 1 click above that, and that is our new y-intercept.
So how do we know that's the asymptote again?
Because we know that this graph right here has an asymptote that is y equals 0. Right, we looked at that earlier. It's erased now. Right? And then this graph has been moved up 1.
Okay,
So if the asymptote was down here, it's now 1 above that. So it's y equals 1.
gotcha.
Are we all cool?
Isn't click like the speed of a ship? You measuring clicks?
No, knots. Click is military speak for a kilometer.
All right, so same thing. We're still sketching. But let's do 3 to the x plus 2. So the only thing that the number changes, the base changes, is just the steepness of the curving. How much bend the hockey stick has in it. Or whatever.
So the coefficient of x.
So the base is 3 in this case, 2 in that case.
I'm done. Okay.
So what's going to happen to our graph this time?
It's going up 2.
Nope.
It's gonna move to the left 2.
Left 2.
Oh,
Right,
because
this
it's
is
and then we
inside
inside,
the function,
yeah.
not outside the function.
Correct.
And it doesn't have any vertical asymptote.
There's no vertical asymptote. However, our original function has a y-intercept. In other words, it hits the y-axis. But our y-axis is now being moved over
Un, dos.
2 to the left. We have a new y-axis over here. Does that make sense to y'all? Just like we did back with the rational functions.
Hold on, so that's a vertical asymptote?
It's not a vertical asymptote, it's our new y-axis.
And the new y-axis will be at 1. Or the new.
I
So-
keep missing like the important key parts because I'm writing things down and then I'm looking up and then you're on something else. I'm just confused, so I
Okay.
don't really get where that's
So, as we already explored earlier today, we don't have any vertical asymptotes.
right.
There are none of those.
Okay.
So we don't have to
So
look
I
for
was
vertical
confused.
asymptotes.
Okay.
But when we were drawing our rational functions, right? So here it is, here's our graph, and we moved the graph over 2 to the right and 1 up. So we moved the origin 2 to the right, 1 up.
Right.
We made a new x-axis and a new y-axis.
Right.
We're just doing the same thing here. We just made a new y-axis,
Okay.
just 2 to the left of the old y-axis.
So if it's like an exponent like that, you just move it to the y-axis to the
Because
left.
it says x plus 2
Gotcha.
to the left.
Okay.
And, as always with these graphs,
Listen to upstairs.
our y-intercept is going to be 1 above the new origin. Right, the old origin was here, the new origin is 2 to the left. And we just draw the same shape again. It's all about finding the asymptote. Oops, that got a little too steep too quick. Or not steep enough, quick enough. Or
So
something
the
like that.
origin, why is the y at 1? Like, why is there a point at 1?
Because anything to the 0 power is,
Oh.
Oh, she's asking about.
and
all
if we
the
plug in -2, -2 plus 2 is,
0,
3 to the 0 power is,
0,
try again,
3.
One more time.
1. Why
1,
did I
right?
add
3 to the 0 is 1.
Yeah.
So we're at -2, 1. -2, 1.
Okay.
That's where our y-intercept is.
Okay.
It got moved over to the left.
Okay.
You good?
Yeah.
All right, and obviously we can combine these two.
In
Let's do this up
the 42nd table.
here. So we can up 1 and left 2. So I'll just make up a different one. Y equals 4 to the x minus 1 plus 3. So what does this mean for our graph here? What have we done with our graph?
Goes up 3.
Up 3 and
To the right one.
to the right 1.
Yeah.
So we're going to go to the right 1 and up 3. So there's our new origin. And we know that our graph always goes through the point 1 above the origin. As we draw our graph, so we go and have an asymptote for there and our y-intercept there.
Confusing with that. Okay.
I like.
Okay.
I'm not gonna say I get this. I'll say I get this.
Good.
But I'm not gonna get it.
We did.
Good luck, video friends.